This video covers exponential functions day 4. So they have given us a graph and they've asked us to use the graph to determine the following. So they want the domain and range. We know that domain is always all real numbers for all quadratics. So you could put the negative infinity to positive infinity or all reals. And then the range, my y's go down to 0 and go up from there, so y is greater than 0. Remember, it does not equal 0 because that's my asymptote. So my asymptote is at 0, my range is greater than 0. The y-intercept, this crosses at the point 0, 3, and my initial value is 3. And then they ask if this is growth or decay. Well, as I follow this along left to right, it is growth. I know this because my graph increases from left to right. So because I read left to right, when I follow it along, I can see that it is increasing. So example 1, they've given us a table and they want us to run StatCalc 0. So I'm going to go to Stat Edit and I'm going to type these in. So 0, 1, 2, 3. Oop. Remember, I click enter between each entry. 2, 6, 18, 54. So here's my table. Now I follow this. I did Stat Edit and then I'm going to go Stat, scroll to Calc. Option 0 is exponential reg, so xreg. It's the exact same steps we've been using. We did 4 for lines, 5 for quadratic, so this is 0 for exponential. So I run this, and so my function is going to be f of x, or y equals. Remember, they always tell you the function here, so a times b raised to the x. So a is 2 times b raised to the x. So 2 times 3, and then a little x. Make sure you do not write it like this because that is a linear function. Make sure it is obvious that your x is in the exponent. Now, based on the table or your equation, which one's your initial value? So my initial value is 2. It's either the first number in your calculator or from your equation, or it is your y-intercept. Does this show growth or decay? How do you know? Well, if I look at my y's, it's going to show growth because my y's are increasing. You could also say that your b value is greater than 1. Your b value of 3 is greater than 1, so it is increasing. And then using this function, find f of x when x equals 6. So we want 2 times 3 to the 6. You have two options. You can type it in just like that, 2 times 3. Remember, this caret means raised to the 6th to get your answer. Or you could plug this into y equals and use your table. Either way. Example 2. They have given us a bacteria population in a petri dish, and they want us to create a table and describe the population growth in words. So I'm going to create my table first. So I have days 0, 1, 2, 3. Once I start getting past day 3, I can't really count, so I'm not going to include that in my data. Day 0 has 1, day 1 has 2, 2 has 4, 3 has 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've created the table describing the growth. It looks like the growth is doubling from day to day. Okay, and then they ask for the calculator steps to find the exponential equation. So I will do stat, edit. I would enter the table, and then stat, scroll right to calc. Option 0, enter 3 times or however many times it takes. Press enter a lot. And those are going to be your calculator steps. Okay, now notice it does not ask you for it, but we could find it if we wanted for a little extra practice. So we're going to go ahead and do that. So stat, edit, we're going to enter the table. And then I would go stat, scroll to calc, option 0, enter, 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 and I could find my equation. And this makes sense. A is 1. That's how many I started with. That's my initial. And then it doubles each day. Example 3, Michelle deposits $300 into an account that earns 7% annually. Create a table of values and write an equation. So I'm actually going to go backwards. I'm going to write the equation and then use that equation to do my table, because I know that I start with $300, that's my A value, and then 1 plus 0.07 is going to equal my B value. Remember, your B value is either 1 plus if it's growing or 1 minus, and it's earning money. Earning money adds to what you have. Also remember to go from 7% to a decimal. We Beyonce it to the left. She taught us how to do decimals. You didn't even know. So in y equals, I'm going to enter this equation, 300 times 1.07 raised to the x. And then I'm going to use that information to go second table and plug in or create a table. Alternatively, if you feel like you could do the table part in your head, then you could use a table to do stat edit and go the other direction. But I didn't feel comfortable with that. So I'm going to fill this in as much as they want. So they want 7 lines total. So I started with 300, then I have 321. So we're just copying these down. And so if you need to pause the video to copy these down, you can. Next, to ask after how much will Michelle have after 15 years? So at 15, she will have $827.71. And this data is discrete because it is deposited annually or once a year. There are no in-betweens. They don't deposit money throughout the year. It's a one-time deposit. So you have this much, then this much, then this much. Okay, the last example, they found this equation. So Julie did some research on car depreciation and determined that the following information about her SUV. She discovered the equation that can be used to describe the table below. So they asked for the car's original value. So the original value is going to be $32,000. That's how much she starts with. Then over time, does this increase or decrease? Well, it decreases. We can see our y's are going down. And remember, this number inside the parentheses is how much it decreases. So it decreases by 15%. Because that's what 1 minus 0.85. They did, hold on. They did 1 minus a percent to get 0.85. So if you undo that, the difference there is a 0.15. Okay. And then they want us to predict the car in 10 years. So I'm going to put this into y equals. So 32 times 0.85 raised to the x. Go to the table. In 10 years, it's going to be worth $6,300. Okay? And then this, you can create your own class list of real-world examples of exponential functions.